Hi, welcome back, Intro Stat students. So today I want to do the modeling data distribution unit test. Now this is unit 4. So let's begin. Okay. So the lifespan of tigers, all right? The lifespan of tigers in a particular zoo are normally distributed. The average tiger lives 22.4 years. The standard deviation is 2.7. Use the empirical rule. This is an important clue. Use the empirical rule to estimate the probability of a tiger living less than 14.3. Okay, and now how does this look like? Okay, so it says here the lifespan is normally distributed. So it's going to look like this, right? A normal distribution with the mean of 22.4 in the middle and standard deviation of 2.7. So I typically like it to be three standard deviation to the left, to the right, three standard deviation to the left. Now, I hope you know by now why I use three and not four and not two, because usually three standard deviation to the right, three standard deviation to the left, this makes up about 99.7%, because this is three standard deviation to the left to the right, this is two standard deviation to the left to the right, this is one standard deviation to the left to the right, and that's why it's called the empirical rule. So 22.4 with a 2.7 standard deviation. Now I want to use this to actually help. Now, so if this is 22.4 in the middle, right? And I should use my calculator, always put it in front, then I can use. Okay, so where was it? Okay, so you see 22.4. Now, every time when I add 22.4 plus 2.7, that's the standard deviation, one to the right, which is 25.1, add another 2.7, and that will give me 27.8. One more time, add a 2.7, and that will give me a 30.5. And then if I take 22.4, subtract 2.7, because now I'm decreasing by one standard deviation. So this is 19.7, minus away another 2.7. That will give 17 right here, minus another 2.7. And that should be 14.3. So this is how the distribution looks like, right? In a normal distribution, and all those areas has percentages that area under the curve is represented by those percentages. So if we go back to the question, it asks us what is the estimate the probability, which is the area under the density curve, right? Of a tiger living less than 14.3. So if I go back to so here, tiger living less than 14.3, which is 0.15%. Right. So hopefully you guys understand that why this is important. Okay. So here we go. The set of sweater prices are normally distributed with a mean of 58 and a standard deviation of 5. What proportion of sweater prices are between 48.5 and 60? So if you quickly sketch a normal curve with the mean of 58 here, now you don't really need to put in the standard deviation if you don't want to, right? So 3 to the right and then 3 to the left. Now, if you're going to do it, that's fine. If you don't, then you need to look at the question and say, hey, this is 48.5, which is really low, right? Like 10 two standard deviation away, because if one standard deviation is 5, then two standard deviation is 10. 58 minus 10, that will give you around that. So I think it's around here. I don't know for sure, 48.50, but that's okay. Where is 60? 60 might be here, right? Might be here. Now, it is an estimate because what they're asking us to find is to find the proportion, which is actually the area under the curve right here. So the area under the curve is, so this is the lower bound. It starts from 48.5, and this is the upper bound. It ends at 60. So if I go to second vars, then I have to pick number 2, right? Normal CDF. And I hope you remember how to do this. We can use this formula function to help find proportion, to help find percentage, to help find uh, probability. So here, the lower is this portion here, this line, which is 48.5, and the upper is 60, right? And the mean is 58 with the standard deviation of 5. So you need to press that again. Ta-da! So round to the nearest 4 decimal places. So it's 0.6267. 6267. 0.6 267. Nice. Okay. So Mr. Dennis gave his class, next question. Mr. Dennis gave his class a 20 multiple choice quiz. The distribution of raw score had a mean of 15 and a standard deviation of 2.5. Mr. Dennis is going to multiply each raw score by 5. So the quiz is worth a total of 100, because if you 20 questions, right? If you 20 questions times 5, right? If each question is worth 1 point, 20 times 5 is, yeah, he's going to make it into 100 points. If each score is multiplied by 5, what will the mean and standard deviation of the distribution of the new score be? Now, if the old mean is 15 and you multiply by 5 for every single score, you need to take the old mean and multiply by 5 too, right? That's how it works. So 15 times 5, that's going to be your new mean. So mean is going to be 75. So it's either C or D. Then you need to look at the standard deviation. The original standard deviation is 2.5. There is one for us, option C is 2.5. But because when you multiply, you are also multiplying the standard deviation. So it's 5 times 2.5, and that gives us 12.5. And we do have one right here. When you're multiplying, right, when you're multiplying each data, right, if each score is multiplied by 5, the standard deviation, the spread, is multiplied by that number, and the mean is also multiplied by that number. When you add or subtract, then the new mean will be added or subtracted, but the standard deviation doesn't change. So next question. Now the density curve, right here it's a rectangle. Density curve below represents the number of minutes after Naledi alarm clock rings that she rises from bed. Which of the following are true? So this is a uniform distribution. You see how it's uniform? It's one straight line horizontally, so it's a uniform. We call it a uniform distribution. The area underneath the density curve is always 1, which is true. And the height of the density curve is 0.2. Now, there is a way to calculate. We don't know what the height is, okay? We don't know what the height is, but we know this. Area under the density curve will always be equals to 1. Okay, we know that much. So how do we find area of this rectangle here? So it'll be h times the width, sorry, the length here is 5. So to get rid of the 5, you divide by 5 on both sides, right? So that's your height here. Your height is equals to 1/5, which is zero point 0.2. So this is correct. The height of the density curve is zero point 0.2, right? It's all correct. Okay. So, oh, another density curve here, which is another rectangle. So consider the following, consider the density curve below. Find the percent. See, they ask you to find percent now, which is area under the curve. The area under the curve represents three things. It represents the three P's, the probability, it can represent proportion, can represent percent. Um, yeah, okay. So find the percent of area under the density curve where x is more than 4. So you're going to shade the part where it's more than 4. So because here is x equals to 4, right? And it's more than 4, so you're shading it to the right. So you're trying to find the area of this rectangle. And the length is 0.25. This is 0.25. And the width here happens to be 1 because 5 minus 4 is 1. And area of rectangle, ladies and gentlemen, is length times width, right? The height times the base. So here, 0.25 times 1 is 0.25. Now, 0.25, we need to multiply 100 to change it to percent, and therefore we have 25%. Okay, so here we go. The distribution of an annual profit at a chain of stores was approximately normal with a mean of 66,000 and a standard deviation of 21,000. The executives conducted an audit of the stores with the lowest 20% of profit. What is the closest to the maximum amount profit at a store where the executive conducted an audit? So I know this question is pretty wordy, right? It's pretty wordy. But what it's saying is this. So you have a normal distribution, okay, and the mean here is 66,000. And we have a standard deviation 1, 2, 3 to the left, or right, sorry, 1, 2, 3 to the left. Okay. Then they ask you to the executive conducted, because this distribution is a distribution of annual profit, right? The executives conducted an audit of stores with the lowest 20% of the profit. Lowest 20%. So now, because this curve goes all the way to infinity, right? It goes all the way to infinity, negative infinity here and positive infinity here. Now, 20% is about, I don't know where, but let's say this area, right? This area, you mark it out because it's the lowest. Up here is the highest 20%. So here, change the percent to decimal, which is zero point 0.2. So the area under the curve, right? Let's say the area under the curve here, and it goes all the way to negative to infinity, right? Negative infinity goes all the way. So this is zero point 0.2. This is how I would shade it, right? On this side of the density curve. Then they ask you what is the closest maximum annual profit. So they want to find this value. They want to find this value where the executive conducted an audit. So this one is the reverse of finding area. The previous question, one of the previous question, we were given all this, and we were given a mean, given a standard deviation, and we were given a range of values to find the area. And then we used normal CDF, right? Second bar. So we use number 2. But this time around, you're given the area, right? You're given the area and you want to find back the data value. Now you go to number 3. That is the reverse of it, right? Reverse. So the area is 0.2, right? For this calculator to work, it always count the area from the left to right. So 0.2, right? It's from left to right. So this is 0.2. And the mean is 66,000. So 66,000. And the standard deviation is 21,000. 21,000. And it asks you, where's the tail? Left tail, right tail, or middle? So you probably don't have this option, but my calculator does. So it's left and then paste it. So this value here is 48,325.95. And they wanted to round this to the nearest thousand. So it will be 4,000, or nearest thousand is right here. So we need to look at this 100 mark. So 3 is less than 5, so it will be 48,000. So we need to round. The answer here is 48,000, which is right here. So this is an important calculative skill that you need to know, is to use the reverse, the inverse norm. They call it. This is inverse normal distribution. Okay, Matthias ordered hydrangeas. It's kind of nice flower, normally used to decorate for a wedding, right? The stem plot gives the diameters in inches of the 35 heads of the flower. So this is 35 heads, and it looks fairly symmetric, all right? And the key is 7/7 means 7.7. So for example, this 6 and a 7, this means 6.7, right? Diameter for this particular flower. So which of the following is the closest estimate to the percentile for the hydrangea head with a 5.2? Where is 5.2? 5.2 is right there. So I need to circle that 5.2, and I need to find out the percentile for it. So I need to calculate, including 5.2, I want to calculate everything, how many less than that. So 5.2, 5.1, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 out of, we were told how many hydrangeas? 35. So 13 out of 35, that is the percentile mark, and we need to multiply that by 100%. So do 13 divided by 15. Oh, wait, sorry, 35. I made a mistake. 35 flowers, right? So 35. I just want to make sure we count again. So we started from here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 divided by 35 and multiplied by 100. So it's approximately 31 percentile. Approximately 37 percentile, which is right here. 37 percentile. Okay, here we go. The employee email accounts in one company are using a mean of 1.07 gigabytes of memory with a standard deviation of 0.21 gigabytes. What will be the mean and standard deviation of the distribution of memory usage in megabytes? Ooh, if 1 gigabyte equals to 1024. So this is like a conversion of the units. Whatever you take, whatever this is, you multiply it by 1024. Okay, so you take 1.07, because that's the mean, 1.07 gigabytes, and you multiply that by how many megabytes? 1024, because 1 gigabyte equals to 1024 megabytes. So you need to take how many gigabytes, multiply by this to get how many megabytes. So how many megabytes? It is about 1096. So we have option C or option D. Then standard deviation. If you multiply, you have to multiply the standard deviation as well. So it's 0.21 multiplied by 1024, and the new standard deviation is 215. Okay. So last question. So here, the distribution of annual profit at a chain of stores was approximately normal, with a mean of 66,000 and a standard deviation of 22,000. The stores with the profit at the top 5% had a reward party. So, judging from the question, right, we draw a normal distribution and the mean is 66,000, standard deviation is 22,000, and they want us to do a store with a profit at the top 5%, right here. So let's shade this top 5%. Now 5% is 0.05, isn't it? You change it to decimal, which is 0.05. And then it's top 5%. Now they want us to find that value, that particular value. We don't know what that value is, but we can find out. So if you're given area, right? If you're given area and you want to find back the value, you need to go to second vars. You need to go to number 3, because that's where you're given area, right? You're given area because number 2 is you want to find area. So number 3 is you're given area. In this case, see top 5% right here is 0.05, but the calculator only can calculate area from the left to the right. So from the left to the right, well, yours do. I actually have a left, center, right. But in to make it consistent for you to understand, this part here will be 0.95 because the area and the total area under the curve is always equals to 1. So if you take 1, subtract 0.05, subtract this away, the rest of it here, the red color one, the area from the left to the right, will be 0.95. And that's why I need to change this to 0.95. And I want to stick a 0.95. That doesn't work, does it? So 0.95. Okay, area is 0.95. And standard deviation is 66,000. The mean is 66,000. Standard deviation is 22,000. Okay, and I want to stick to the left because your calculators do not have center, right, left. I want to make it consistent for you because the calculator would calculate from the left to the right 0.95, right? Because I want to find this value, this value. So paste, ta-da! So this value, ladies and gentlemen, is 102,186.8. Round to the nearest thousand. So nearest thousand, I need to look at this number, which is 1. So you round down. So the answer is 102,000. So it's about 102,000. 102,000 right here. So if you have any question, please ask your teacher. Thank you very much.